give you an example of how requirements can change when you're designing for an emerging market, a classic example would be, say, a fluoroscopy machine. If you build one in the United States and you obtain approvals and you try to sell it in emerging markets, you'll sell a few, but you may need to make changes such as putting bigger wheels on it, which would seem to have nothing whatsoever to do with machine performance. However, a hospital there will only own one machine, and they may move it around and utilize it quite heavily. And in fact, having big rubber tires on it will make all the difference between that machine surviving 6 months or being warranty serviced immediately, which then brings us to business models. So there are significant differences in the business models here, and that's obviously in Europe, as well as in the emerging markets, and we need to better understand those business models, especially in the emerging markets, if we are to provide better care to the populations. If I'm to sum up my area of particular interest, it's wherever humans and machines come together. That's obvious in healthcare, where clinicians use tools to perform procedures on patients, but also in food services, in assembly lines, where technicians have to make adjustments to equipment. So there's a wealth of opportunities to improve the experience for workers, for clinicians, for people throughout the world in terms of human factors. One of the most exciting parts of my work is bringing physicians and teams of engineers together to work on design projects. So the clinicians in the Boston area were lucky. They're very willing to share where they think their practice can be improved. We put them together with student teams, and we do this under the guise of our medical device design class, which features electrical engineers, mechanical engineers, HST students, and a couple of other random folk from around MIT, and a really cool teaching team of which I'm part. But we take the students and the clinicians together through a structured design process that really focuses on extracting the clinicians' real needs, developing a deep understanding of why they do what they do, how it could be improved, generating a whole set of concepts and strategies and actual designs, and then proving it out through actual physical proof of concept prototypes that we can then take into clinical settings and test them out. And this is all done in a 14-week process. So those prototypes then develop a life of their own. Some are of academic interest, they become a paper, and that really helps students and clinicians' careers. Some continue on as lab and research tools, so we've built devices in the past that have helped clinicians understand how to grow tooth buds, and others have become products. Right now there's 3 products in the market, or soon to be. One is the Mimo Baby Monitor. It started out as a sleep sensing shirt developed with Matt Bianchi at Mass General, and today it's available on Amazon and Babies R Us, and that technology all started in the medical device design class at MIT. We have a really nifty syringe system coming, as well as an improved tourniquet that's starting to attract interest, and those are just in the recent few years. And of course, some of these projects also continue on to graduate level research and master's and PhD theses.